Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the modern periodic table, which is also known as long form of the periodic table. So initially, let us know in brief about the history of periodic classification of elements. So initially, a scientist called as Dauberinian, he classified the elements into triads based upon the atomic weight, and the theory is known as Dauberinian's triads. So he classified the elements as the triads. So best examples are lithium, sodium and potassium. So these three are called as triads. Similarly, calcium, strontium, barium can be called as a triad. So according to Dauberinian, so when we consider the atomic weight of the middle element, it is the average of atomic weights of the other two elements. So in that way, he classified all the elements into triads basing upon the atomic weight. Later, a scientist called Newland, he classified the elements as Newland's octaves. So he also classified the elements based upon the atomic weight into octaves. So according to Newland's theory, whenever if we consider elements, the properties of first element is similar to that of eighth element which is followed by it. So and hence the theory is called as Newland's octaves theory. Let us see the best example. So whenever if we consider hydrogen, fluorine and chlorine, they can be called as Newland's octaves. The properties of hydrogen are similar to that of fluorine. The properties of fluorine are similar to that of chlorine. Later, Mendeleev, he proposed the periodic table. So according to Mendeleev's theory, he also proposed the periodic classification based upon the atomic weight. So he proposed a theory. According to Mendeleev's theory, the physical and chemical properties of the elements are the periodic properties of atomic weight. At the same time, he introduced two terms known as periods and groups. So for the first time, he proposed horizontal rows as periods, whereas the vertical columns as groups. But this theory is associated with one main drawback. This periodic table is associated with several blank places. Why? He classified the elements as the periodic functions of atomic weights. With the result, several blank places are found in Mendeleev's periodic table. Later, a scientist called as Moseley, he proposed the modern periodic table, which is also called as long form of the periodic table, and it is the most agreeable periodic table. At present we are using the Moseley's modern periodic table. So according to Moseley, he proposed that the physical and chemical properties of the elements are the periodic functions of their atomic number. So atomic number is the most appropriate term to define the physical and chemical properties of the elements. So which is the most appropriate term to define the physical and chemical properties? Atomic number. At the same time, the modern periodic table also follows the electronic configuration. So here the elements are classified according to atomic number and also electronic configuration. So this modern periodic table can be defined as the graphical representation of Aufbau principle. So simply here all the elements are classified according to the atomic number or electronic configuration. So whenever if we use the term electronic configuration, it is more appropriate to follow the Aufbau's principle. So the modern periodic table strictly follows Aufbau's principle, and hence it can be considered as the graphical representation of Aufbau's principle. Let us see the outline of the modern periodic table. So, the modern periodic table consists of groups and periods. This is the outline of modern periodic table. Generally, the modern periodic table can be classified into 4 blocks. It is called as S block. So, the extremely left hand side block is called as S block, which consists of 2 groups, first group and second group. So, first and second group elements are called as S block elements. Remember students, always the modern periodic table consists of 7 periods and 18 groups. So, according to modern periodic table, how many periods and how many groups are present? It consists of 7 periods and 18 groups. So, the horizontal rows are called as periods. 3, 4, 5, 6, 7. So, it consists of how many periods? It consists of 7 periods. At the same time, it consists of 18 groups. So, how many groups are present? 18 groups are present. For simplicity, the modern periodic table can be classified into 4 blocks. So, first 2 group elements are called as S block elements, and the extremely right one, that is the 18th group, is called as 0 group elements, and from 13 to 18 These group elements are called as P block elements. So they can be called as P block elements. So what is the nature of S block elements? S block elements are electropositive. So what is the nature of S block elements? S block elements are electropositive. Whereas P block elements are electronegative elements. So S block elements are present extremely on the left side, whereas P block elements are present extremely on the right side. In between there exist D block elements. D block elements starts from 3rd group to 12th group. So why they are placed in between S and P block elements? If we carefully observe the properties of D block elements, the properties of D block elements are in between S block and P block elements. That means they are less electropositive than S block elements and less electronegative than P block elements, and hence the position of D block elements, that is in between S and P block, is justified. They can also be called as transition elements. So what is the other name for D block elements? They can be called as transition elements. Why? They shows transition in properties from S block to the P block elements, and hence they can be called as transition elements. For the convenience, the F block elements are placed at the bottom of the periodic table. So if F block elements are present in the long form of the periodic table, it becomes very long and it is difficult to remember. So to make convenient to remember the periodic table more easily, and also it is the appropriate classification. Why? The properties of F block elements are completely different from that of S, P and D. So when we consider F block elements, so they shows transition within the D block elements. So the properties of F block elements are in between the D block elements. So they are showing transition in transition elements, and hence they can be called as inner transition elements. As they shows transition in transition elements, they can be called as inner transition elements. So the long form of the periodic table can be classified into 4 blocks: S block, P block, D block and F block. Let us see in detail about the modern periodic table. So the modern periodic table is called as long form of the periodic table, and according to Mosley, the physical and chemical functions, the physical and chemical properties of the elements are the periodic functions of their atomic number or electronic configuration. At once, let us see the modern periodic table, which is also known as long form of the periodic table. It consists of 7 periods: 1, 2, 3, 4, 5, 6, 7. So the horizontal rows are called as periods, whereas the vertical columns are called as the groups. So the first and second group elements are called as S block elements. When we consider 1A group elements, they can be called as alkali metals. Why they are called as alkali metals? They are strong bases. So when they are treated with water, they results in the formation of strong bases, and hence the 1A group elements are called as the alkali metals. So we have to remember S block and P block elements. So let us classify them into groups. So 1A group and 2A group elements are called as the S block elements. Let us see first group elements. So here the groups are classified into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It is the modern scheme of classification. According to old scheme of classification, they can be classified as 1A, 2A, 3B, 4B, 5B, 6B, 7B, 8B, 1B, 2B, 3A, 4A, 5A, 6A, 7A and 0 group. So the modern scheme of classification is very convenient. Let us follow the modern scheme of classification. So coming to the first group elements, it includes hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So these are called as alkali metals. Why? They form strong bases with water. And coming to the second group elements, they includes beryllium, magnesium, calcium, strontium, barium and radium. So they are called as alkali earth metals. Why? They also forms bases with water, but they are weak bases when compared with the alkali metals, and hence these second group elements are called as alkali earth metals. That is about the S block elements. Coming to the P block elements, let us see the 13th group elements. 13th group elements are called as boron family. It includes boron, aluminium, gallium, indium and tellurium. Next, coming to the 14th group elements, they can be called as carbon family. It includes carbon, silicon, germanium, tin and lead. Coming to the 15th group element, it is called as nitrogen family. It includes nitrogen, phosphorus, arsenic, antimony and bismuth. Coming to the 16th group element, it includes oxygen and it is called as oxygen family. So it includes oxygen, sulfur, selenium, tellurium and polonium. Coming to the 17th group elements, it is called as halogens and it includes fluorine, chlorine, bromine, iodine, astatine. And coming to the 18th group element, it includes zero group element or noble gases. They can be called as helium, neon, argon, krypton, xenon and radon. So this is about the P block elements. And I think generally the students are familiar with the elements having atomic number up to 30. So coming to the D block elements generally consist of 3 periods. Okay, 4th period elements, 5th period elements and the 6th group, 6th period elements, 7th period elements. So it consists of 4 periods. So coming to the 4th period elements, it includes scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. So you just remember up to 30 elements. So 3D elements generally includes scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Coming to the 4D elements, it starts from yttrium and extends to cadmium. 5D elements includes from lanthanum to mercury. And after lanthanum, we will get F block elements. So they are separately placed at the bottom of the periodic table. So lanthanides are called as 4F block elements, whereas actinides are called as the 5F block elements. So coming to the 6D elements, they consist of actinium and the other elements. So this is about the classification of elements in the modern periodic table. So S block elements are present extremely on left side. P block elements are present on extremely right side. In between, D block elements are present. At the bottom, F block elements are present. That is about the modern periodic table. If you like the video, don't forget to like, share and subscribe. Thanks for watching.